The next concept in this particular section that we're focusing on is law of cosines. So we've studied law of sines at this point, and we saw that we had a nice formula that we could use to find missing pieces of a triangle using the law of sines, and we also have the same idea for law of cosines. First thing that students typically scoff at when they look at these formulas for law of cosines is, oh my gosh, I essentially have 6 formulas in front of me. So it just seems a little overwhelming. The formula itself is also just a little bit more complicated than what law of sines was. It's just kind of the beast that you're going to have to deal with law of cosines. Hopefully I'm going to break it down for you so you realize that really these 6 formulas are not all that difficult. Even looking at them, you may notice that there are a couple patterns that might help you remember them. And I mean, really, the rule of thumb here, folks, you really don't need to memorize 6 formulas. If you know one, you really know them all. Whoa, let me get rid of that crazy yellow line. Okay, sorry about that. Um, but like I said, if you know one of these formulas, you should be able to get them all. So this particular one, we would be able to solve for a missing side A by using this formula. And if you look when you're solving for B, the formula is very similar. We just have to interchange a couple of our side lengths and angle measurements. Same thing when you're solving for C. Formula is set up very similar, but you have some of your A's, B's, and C's kind of flipped around. So, if you can find this pattern, memorizing just one of these, you should be able to get any. Now, where did these formulas over here come from? Because this formula is helping you solve for angle A by using cosine. This formula didn't just pop up out of the blue. If you manipulate this formula and solve for cosine of A, you will end up with this formula. I'm going to just show you the work for that down here. If I want to get cosine of A by itself, I'm going to start by subtracting the b squared and the c squared. So I have a squared minus b squared minus c squared equals a negative 2bc cosine of A. And now I'm going to just divide both sides by the negative 2bc. Now when that happens, all these signs are going to change because of this negative. So I really have a negative a squared plus b squared plus c squared all over a positive 2bc. So I basically switched out my signs here. And then that is equal to the cosine of A. The only thing different in the way the formula was written up here is the b squared and c squared come before the minus a squared. So that's really easy to just interchange. And then in order to figure out what angle A is, you're going to have to do the inverse cosine of whatever this fraction, whatever this decimal ends up being. So again, I know the formulas can seem a little overwhelming, but in reality they are not that difficult to figure out if you can look for the pattern, and if you realize that you can take this one and work it backwards for the cosine of A, you would know how to get all 3 of these as well. Hopefully that helps, and as you work with these formulas a little bit more frequently and on homework, I think you'll start to realize that it's not that bad. Again, why are we using this formula? And that is to find missing angles and sides in a non-right triangle. And I would say most people would agree with me, you only need to use law of cosines if law of sines is not going to work. Because obviously we just discussed law of sines is easier. So if you can use it, then use it. Couple of things that you definitely want to be careful about. Number one is, and this is actually a good thing, when you are using law of cosines, there's no 2 triangle scenario. 2 triangles will not be a possibility. A reason why, and maybe this, hopefully this makes sense to you, When we had to find the two angle possibility with the law of sines, it was because when we did the inverse sine of some number, we knew that there was an answer in quadrant 1 and in quadrant 2, as long as this number was positive. If we're doing this with law of cosines, we are going to be doing the inverse cosine of a number. Now, what do we know about cosine being positive? Our answers do not come from quadrant 1 and 2. Our answers come in quadrant 1 and 4. Folks, you can't have an angle in a triangle that's in quadrant 4. It's impossible. It's too big. That's why quadrant 1 is the only option when you're doing the inverse cosine. So this is usually something that makes students pretty happy. Something that definitely can be a problem is, and we'll see some examples of this as we go through a problem together, when you start using law of cosines, after you've found a missing piece, many students choose to switch over to law of sines afterwards. There are some pitfalls to this. Again, I said I would try and show you those. Some students still tend to not believe me and they just switch to law of sines and don't think about anything. But it really becomes a problem if you haven't found the biggest angle yet. And I'll hopefully be able to explain that to you as we go through. But word of kind of the way to stop yourself from falling into any pitfalls is when you're using law of cosines, make sure you've found the biggest angle before you switch back over to law of sines. That way you don't have to encounter this two situation again. This is actually something you really want to watch in both formulas when you're using them. Make sure that when you are rounding, folks, you round as far as you possibly can, because if you round out 1 decimal place or 2, you're going to be skewing any answer you get after that. So if you can keep the decimal in your calculator, I'm actually going to show you in class how you can actually store a number in your calculator. Some of you maybe have already figured that out. But you want to always try to not round your answers, and that's going to give you the most exact answer at the end. All right, let's look at the first example. Hopefully it looks very obvious to you as to why law of sines does not work. We don't have an angle A and side A information. We don't have an angle B and side B information. We don't have angle C and side C information. We have basically an A, a B, and a C kind of all separated. So law of sines can't work. We can't set up the proportion. So now is where we use law of cosines. From the information that I've been given, I am going to have to use the formula that is going to help me find side C. So that formula is C squared equals A squared plus B squared minus 2AB times the cosine of C. Some students figure out how to put all of this in their calculator at once. That's totally fine by me. I would say just be careful with this minus and make sure you are subtracting this entire quantity. So an extra set of parentheses wouldn't hurt you here. Also, at the end, realize that what you are going to get here is representing C squared, and I get 489. And then keep this number entirely in your calculator, but I get approximately 489.347. And again, I'm keeping this whole thing in my calculator, and then I'll square root it, and my best answer here is going to be 22.12. I'd say just as a rule of thumb, we're probably going to go out 2 decimal places and try and stay accurate that way. But now we know what side C is. Here's the issue, folks. Now that you have a missing side length, law of sines can actually work at this point. If you look at your side lengths, you will see that we have not found the biggest angle yet. Biggest angle is going to be angle B. Now I am going to go ahead and switch to law of sines and show you the mistake that people make when doing this, so that hopefully you'll be conscious of it and you'll understand how to make sure you don't make the same mistake. All right, so I'm going to use law of sines with my C information, side C over angle C equals side B over sine of angle B. Again, you can go ahead and do your cross multiplication here. Um, Basically, we are going to have that the sine of B is equal to 30 sine of 42 divided by 22.12. When you do this, you're going to have to do the inverse sine of this decimal. So I want you to go ahead and do that in your calculator and make sure you end up with the same answer as me. When I do that, I get 65.16 degrees. Now here's the problem. People remember, well, Mrs. Horn said with law of cosines, there's not a two-triangle possibility. So they don't think about it at all, and they just go with every answer they get. Well, here's the issue. It's not that there's going to be a two-triangle possibility, but folks, this angle might not be the right angle B. This is angle B for quadrant 1. What about angle B for quadrant 2? And since you were doing this with sine, you have to consider that second possibility. If you do the quadrant from angle 2, you're going to get 114.84. Now, let's think about what our last missing piece is going to be and how we're going to know which one of these actually works. We are missing angle C. In order to find angle C, you know A and B, I'm sorry, we don't need angle C, we need angle A. We know angle B and C at this point, so it should be pretty easy for you to find A just from subtracting from 180. If you use this as your angle B, the 65.16, what most people would use because it's the first answer they got, you will get a 72.84. If you use the second quadrant angle B, you will get 23.16. How do we know which one of these is accurate? Compare your side lengths. This angle A is bigger than this angle B. Do you remember us saying that angle B has to be the biggest angle because the side B is the biggest side? Therefore, this cannot work. And your right angle measurements that are left over must be these two. This is one example of where switching to sines can definitely cause some issues. You might be wondering, oh my gosh, how can I avoid this pitfall? How can I avoid doing this? Folks, if you don't switch to law of sines, you won't have the problem. If you would have used law of cosines to find angle B, yes, it's a longer formula, but this is the answer you would have gotten. Now, if you don't believe me or you just want to try it, try doing law of cosines to solve for angle B with the information we have, and you will get the 114.84 on the first shot. Now, if you dislike the formula so much that switching to law of sines is going to be what you do, you need to watch for this possibility and be able to check and make sure your angles and your side lengths match up at the end according to the rules of geometry. We can talk about this again in class if for some reason this still doesn't really make sense. But again, if you're scared that you're going to make a mistake, my best advice to you is once you've started with law of cosines, Just use law of cosines to solve the rest of the problem, and you should not run into any problems. All right, my next problem, I've given you three side lengths, no angles. So obviously law of sines does not work. Um, I can solve for any angle that I want. If you're thinking you're going to want to switch to law of sines, my advice then would be find the biggest angle measurement first, and then you're not going to have to worry about making a mistake with law of sines. So I am going to find angle C first. Remember that your formula, if you want to kind of check back with your formula, for the cosine of angle C is going to equal your a squared plus your b squared minus c squared all over 2 times a times b. This is another one that a lot of students like to do this all at once in their calculator. Make sure your numerator is in parentheses and that when you divide, your denominator is all in parentheses. That way you don't make any mistakes. Get this decimal, keep it as a whole in your calculator. I get negative 0.42614. Again, probably a little bit more. Leave it. Do the inverse cosine of this decimal, and you get 115.22 degrees. Now that we've found the biggest angle, it's in quadrant 2. The other two angles are going to have to be in quadrant 1. Therefore, if you switch to law of sines right now, you should not make a mistake. If you still prefer to just stick with law of cosines and just stick it out through the problem, you should not make a mistake either. So you have an option at this point as to what you feel the most comfortable doing. Because most students do choose to switch, I'll go ahead and just show that work here. 15, I'm going to find sine of A, so angle A is what I'm going for next. And then I'm going to use my information for C, which side C was 20, over angle C that I just found. So if you can cross multiply and divide, and then you're going to have to do the inverse sine of what you get. Let's see, you're going to have a 15 sine of 115.22 divided by the 20. And when you do the inverse sine of that, you should get your angle A, which ends up being 42.73 degrees. And now that we know two angles, we could pretty easily solve for angle B by subtracting from 180. For those of you true mathematicians out there, something I would maybe recommend doing as well, just to kind of prove that you really have not made a mistake at this point. I see a lot of students that actually, instead of taking the shortcut and subtracting from 180 here to get angle B, they use the formula and they get angle B, and then they make sure that their angles truly add up to 180. So if you use your formula to find the 22.05, that's a really great way to double check and make sure you've made no mistakes with any of your values up to this point. So a couple things to think about with law of cosines. Again, we'll touch base tomorrow and do some more problems together.